In today's video, we're doing something a little different than what we've done in past episodes. We had the awesome opportunity to go inside the historic Philipsburg Waterworks and document its incredible Allis-Chalmers vertical triple expansion steam-powered pumping engine built in 1913 with its surrounding controls, machinery, and boiler house. Join us as we kick off our Industrial Heritage series, in which we will showcase historic industrial sites that are actively being preserved for generations to come. Constructed in 1913, the pump house engine boasted a capacity of 42,000 gallons per minute, equivalent to over 6 million gallons a day. The following year, a backup steam turbine pump was also installed with an identical pumping capacity as the VTE. While the turbine required all 4 boilers to supply steam, the Allis-Chalmers VTE typically only required 2. The plant operated until 1969, when a new well system was put into service and the site was put on standby status, having test runs annually until 1982, after which the site sat unused and abandoned. Thankfully, in 1999, the plant was acquired from the utility company and leased to the Friends of the New Jersey Transportation Heritage Center, who are the current caretakers for the site. As part of that deal, the deteriorated roof was replaced to help in the preservation process. There are long-term plans to restore the facility and open it to the public for tours, in addition to getting it listed on the National Register of Historic Places. To say we were in awe of the craftsmanship and detail in the waterworks would be an understatement. From the engine to the boilers, the attention to detail in these historic industrial machines was a special sight to see.
Yes, you have to lubricate things with it. You also have to check. This engine is not so bad, but I know some people who want not different shifts. The way they check, they made them and the cost of it, you have to stick your hand. Why much work? About 48. So you have to look at it.
Fire extinguisher. A little closer to the boiler. The cool gauge.
Perfect explaining to you all of this. Because what it is, it's a graphical representation of what's going on inside of these engines. Try to describe it, but
It was a long way down.
it's a device that has two components. So there's a tank there, takes oil, goes to this line, through the tubes, comes into here. These feed to
You want to carry it up the stairs now? Thing's crazy, isn't it?
Because they didn't have a second engine, they needed a backup for the first one. They installed this stupid thing. So, we'll start this process at the wrong end, which is also the right end. Steam comes in, so they added a T in, comes down, a set of rollers for the pipe to sit on, another condensate separator, comes through the valving, all sorts of complicated gubbins. There's a governor in here, there's an emergency trip stop, so if it overspeeds, it just shuts everything down. I don't know how much you know about turbines. Basically, it's a fan in a box, but also not, because there's stationary blades that redirect the air. This has 4 nozzles on it. You can run it down to just one if you so choose. I don't remember how many stages it is. I think it's like 4 or 5. It's not that big at all. But yeah, high RPM. What was it rated at? Yeah, I think it was 4,040. 525 horsepower. This is where this machine gets really bad though. 125 psi steam. If you know how turbines like to run, you're going to go, are you kidding me? That is so low. 125 psi saturated steam? Huh? Oh no. That's our first problem. After that, it goes. After that, I trip on a railroad crossing sign that wasn't here last time. Run through our fuel reduction box, which does not have a reduction marked on it, but I think it was a 30 to 1, if I remember. After that, it goes through 2 pumps. These are made by Cameron, the centrifugal pumps. So unlike that, where you've got a piston moving up and down and it has to push water out, this is just spinning the water really fast to throw it out. There's 2 of them. They're series together, so it comes up through this one and then outflow. This one goes into this one, which then kicks it out to the city main. Actually, no, I got that backwards. Comes into this one, goes out into that, and out. And then on the very end of all of that is a DC electrical machine. I call it an electrical machine because technically you can run this as a motor if you really want to. It's set up as a generator. So, what it makes is 220 volts direct current. It's being spun by all of this. Now, mind you, to get this thing spinning, you already have to now be spinning 2 centrifugal pumps completely dry, which is what that's supposed to do. But now that that's spinning, it's making electricity. Now the electricity comes all the way back this way. Through this panel. There's a few things here. There's a main disconnect, which is what connects to that generator. Then you've got a motor starting panel. There's also a field rheostat for controlling the exact voltage on that dynamo. It was never hooked up. It's there, they never used it. You've got 2 gauges, you've got voltage and amperage. Voltage, I want to count to about here. Amperage, how much load you're pulling. After that, you've got a few other things. This is all for starting that motor. But I'll get to that in a second. What this motor is doing is I pointed out there's a centrifugal pump all the way down to the bottom. That pump is your lift pump. The problem with centrifugal pumps is that they do not suck. They are horrible when drawing up into themselves. They will run fine when they're already primed and full of water, but they don't like it when they're not. And there's no way in hell those two pumps, even ganged together in series, could lift water from the bottom of the pit. So they have to have another pump in the bottom of the pit that is low enough that it can start suction that pushes water all the way up to these two pumps. They go one through the next and then out to the city. So really, you have 3 pumps in series. 2 driven by a turbine, 1 driven indirectly by a turbine via an electric drive, sort of an electric transmission. And then to make matters even worse, the condenser setup is completely done incorrectly, and it just vomits all the condensate out the side of the building. So this machine was an afterthought. It was not meant to be here. But here it is. And when you guys look underneath later, you'll see they had to chisel away part of the wall to fit some of the machinery down there. But what I'll do now is something we got set up here pretty early on. I'm going to actually run that motor. So I will say be careful, things are about to get electrically live. So first thing to do, check that everything is in the right position. So this is our main bus disconnect, so I'll make everything live. Right now the gauge is being a little weird, so it's reading high, but it's fine. This contactor, we won't talk about that. There's actually a dead man system in this, so when you're starting this motor, this is a soft starter, basically, so you're not starting it all the way to power at once. This goes through a series of resistors, which allows the voltage to come up slowly, and your speed to come up slowly. And you, as the operator, are running it, both watching the machine and the ammeter. Of course, you want to have a safety measure, so let's say you're doing this and suddenly something bad happens. Well, to run the motor, you have to turn this. By turning this, what you're doing is applying contact pressure to a little inset rail in there, which is applying power to that coil, which is holding that contactor shut. So that way, if you're turning this along and you let go of it, it shuts the motor off. Until you're all the way around, then it bypasses and you can let go of it, it's fine. You can walk away. In this case, that contact rail is kind of shot, so we have to do some bypassing. This is the circuit breaker, so if it overloads, that trips the breaker. We kind of have to use it as the main switch right now. I'm not going to do what Alex does and burn the contacts out and show you a DC arc. He loves to do that because he's got a big fireball out the top. But I'm going to not do that and try to get it to stay in because sometimes it'll come out. Now, a word of advice, if you're running an old panel like this, you only touch it with one hand. And your other hand should really be behind your back. Because, let's say I touch this and something else, and I'm potentially now part of a circuit. Especially if I'm leaking all the way across and I'm on ground then, and I'm screwed. I got 200 volts across me. It's DC. AC, it'll throw you. DC, you know when someone's on a DC arc because they clench into what's killing them. And also, that's why if you see someone on DC, you don't grab them, you kick them. Because if you grab them, now you're part of the circuit, you're stuck. So, you'll see that I'm actually very careful with these. So, let's see if this relay stays in. Comes. There go all the spiders turning into plasma. So now that that's sort of leveled out at speed, I start moving this. You'll hear it speed up. And this is slowly, as it moves, cutting out resistance. There's a resistor grid on the back. As I turn it, it's disconnecting more and more of them. The ammeter isn't really moving because there's no load on it, but I've ridden that all the way around. Now it's at 0 starting resistance. Now, how do you control the fine speed? That's this. So, motors can be speed adjusted by field shunting. If you add resistance back to the field, it'll actually cause the motor to speed up. If I want to make this motor go quicker, I may actually lose in this case, depending on someone. Okay, there it is. Alright, someone left it in the high position. But now the field is, all the way down. So that's its low speed. If I crank this back up, you'll hear it kick back up to speed again. So that's how you fine adjust the speed. Let's do it run like that for a minute.
Got that electrical now. Love it.
Hey, these things are hard to start smooth. Yeah?
It might be the rods and the holes.
Okay.
It might be, we'll have to find out. What do we got? We got 5 on the receiver.
Thanks for watching today's video. We'd like to thank the caretakers for giving us permission to see this amazing piece of industrial history. For more information on the Waterworks and to learn how you can support the preservation efforts, please visit the link in the description below. If you enjoyed this video, make sure to also both like and subscribe to get notified when new videos are released, and also make sure to follow us on Instagram and Facebook to see photos and live videos from all of our explorations. You can find links to those in the description below as well.